To understand better about the mole concept, let's try to tackle this problem. Alloys of palladium and nickel are often used in the manufacture of electronic connectors. One such alloy contains 70.8 mole percentage of palladium. Now we are asked to express the composition of this alloy in weight percentage. How do we solve this problem? In principle, we have the N, mole, and then we have to convert it to mass, in this case with the unit of gram. And of course, we would have to use this following formula. N is the same with the mass divided with the molar mass, or in this case, because it's an element, it's equal to the AR. So first we can find the M for PD. Assuming that we have 100% mole or 100 mole for this component, so we have PD as NPD times the AR of PD, which is 70.8 times, you can check the periodic table and then you will find that it is 106.42, so we will get the value of 75.4 gram PD. While the mass of nickel will be, of course, the mole of nickel times the AR of nickel. The mole of nickel, if we assume 100 mole, of course is going to be 100 minus 70.8. And then times the AR, which you can check again in the periodic table, that is equal to 58.69, and then you will get the value of 17.1 gram of nickel. So in this case, the total mass will be 75.4 plus 17.1, which is equal to 92.5 gram of alloy. So the percent weight for PD will be 75.4 divided by 92.5, and don't forget times, of course, 100%. And you will get the value of 81.5 weight percent of PD, while the percent weight of nickel will be 100 minus 81.5, which is equal to 18.5 weight percent of nickel. Now, the mole concept is also useful to determine the empirical formula. Let's check this problem out. Nitroaniline is composed of 52.17% of carbon, 4.38% of hydrogen, 20.28% of nitrogen, and 23.70% of oxygen by mass. Based on this data, we are asked to determine the empirical formula for nitroaniline. How do we solve this problem? We know that the empirical formula will give us CX, HY, and Z, and OQ, for instance. Yeah, so you have 4 elements and then you will have 4 different numbers representing the ratio of these 4 elements in the nitroaniline compound. So we tackle this by first calculating the mole for each of the element, assuming that we have 100 gram in the beginning. 100 is an easy number for you to assume because we use percentage, and of course everything will make up to 100 gram. So in this case, we can write down that the carbon has 52.17 gram, the hydrogen will have 4.38 gram, the nitrogen will have 20.28 gram, and the oxygen will be 23.17 gram. To find the mole, we have to divide all of these values by their corresponding AR. You can check again the AR in the periodic table. For carbon, it's 12. For hydrogen is 1. For nitrogen is 14. And for oxygen is 16. And if you divide this, you will end up with 4.34, 4.35, 1.45, and 1.45 as well. So first, you have to calculate the mole. Find the mole first for each of the element, carbon, hydrogen, nitrogen, and oxygen. Assume 100 grams for all of the materials together, so you get the mole for each of the element. And now you can find the empirical formula, which is C 4.34, H 4.35, N 1.45, and oxygen 1.45. Now, normally, the number that we use here has to be a whole number. And we can see that here, they're not whole number. Now, the common mistakes made by students is that they try to round up this number. So, this is like 4, and then 4 as well. And then this one is perhaps 2 or 2. Now, this is wrong. Okay, one more time. I emphasize that this is not the right way to do it. You don't round up or round down these numbers. So instead, what you do is you have to divide with the smallest number in the mix. So in this case, you can see we have more or less 3 different numbers: 4.34, 4.35, 1.45, and 1.45. What we do is that we divide this by the smallest number in the mix. So in this case, divide it with, of course, 1.45. And then after that, you round them up. So in this case, you will get N, 1, O, also 1. And actually, if you divide 4.34 with 1.45, you will get more or less 3. So carbon 3, hydrogen is also 3. In conclusion, for this problem, the empirical formula of nitroaniline is C3H3NO. Final answer.